Bridges have been created for humans since the beginning of history. They are made to allow physical connection between two sides of a river, estuary or chasm and have resulted to be of key importance in economic, political and social issues. Economic because allow easier and faster transportation of merchandise, which means time savings and thus cost falling. Politic because they can make two different cities or even countries to be in easier contact with each other. And social, since people who crosses the bridge got to know people on the other side, and since they give freedom to move through the landscape. From the architectonical point of view, there are three principal types of bridges: the beam bridge, the arch bridge, and the suspension bridge. The beam bridge is the simplest type and it works as a simple beam supported by the sides. The principal problem of the beam bridge is that the spans between their columns depend totally on the material in which the bridge is made and is the height of the beam. If the beam is too high, the bridge becomes heavier, so the span used to be little, and that makes this type of bridge useful only in short distances or in non-navigable rivers. In the arch bridge, the principal loads of the bridge is in the form of compression, and thus the first arch bridges were made on masonry materials as stone or brick, but nowadays they are made of plenty of materials as steel or reinforced concrete. The arch system is much better than the beam bridge because it allows bigger spans between the columns, but it has a limit as well. The suspension bridge has come to be the iconic bridge image for excellence, and its technology has come to allow the biggest spans between columns ever. It consists in a certain number of huge columns named towers, usually two, from where hangs super resistant steel cables from which hangs the deck of the bridge. At the end of every side of the bridge, these cables end tied to the anchorage, which grab themselves firmly to the ground. The only problem of the suspension bridge is that it's not as rigid as others, and are vulnerable to the destructive effect of resonance if are not carefully calculated. Another type of bridge, the cable stayed, is a kind of suspension bridge in which cables go directly from the towers to the deck diagonally. This makes it more stable than the usual suspension bridge and makes the anchorage unnecessary. While investigating about bridges, I found this beautiful arch bridge in Switzerland called the Salgnatobel Bridge, characterized by soft and delicate lines and made entirely in reinforced concrete. It jumps a steep gorge of 19 meters height and is located in a stunning landscape, without any other human construction outside, in the middle of the Swiss Alps. It was made to connect two little alpine villages, Schodas and Schiers, in the valley of the river Landquart. The incredible thing about this bridge is how modern does it look, but it was actually made in 1930 by the Swiss engineer Robert Meillat. Meillat is today known as one of the top engineers of 20th century. He designed and built more than 40 bridges in his life and is known for being one of the pioneers of the use of reinforced concrete. His bridges are characterized for showing naked structural elements, but as well for being elegant and simple. At the moment the Salgnatobel Bridge was built, usual concrete buildings were covered to imitate other materials as brick, but Meillat had this modern ideal of honesty, so he let concrete be totally seen, which is very thanked nowadays. Structurally, the bridge consists of the deck of 132 meters long and only 3.5 wide, the supporting arch which saves a span of 19 meters, and a group of vertical walls that make the connection between them and the sides of the bridge. This is very important because one of the contributions of Meillat to the building of arch bridges is precisely the independency of the arch and the deck, which allows saving materials and making the bridge lighter. The arch has 3 jointure points, being the center of key importance, and is different of many usual arches for its low height, which is possible because of the distinctive position of the bridge, like pressed between the mountains. The building of Salginatobel Bridge is now a known process to us, but in the moment it was very different from the building of other bridges, especially from metallic ones. This is because to make the formwork to pour the concrete was practically necessary to build another bridge but wooden, which was made by the engineer Richard Gray, specialist in these ephemeral structures. The context where the bridge is placed is very important to the concept that Maillard had of the bridge. We're not talking here about a big insignificant bridge with huge towers and amazing colors, and neither about constant transit, lots of people or noise. The fact that the deck is 3.5 meters wide, rather a modest size, makes us understand how little this project is, made for the necessity of only 2 little towns. Besides, the project, in contrast with what many people could believe, was selected between 19 different projects not because of formal or technical matters, but because it was the cheapest option. Here's one of the proofs that a masterpiece of architecture or engineering is not necessarily a huge and expensive one. The bridge, except for a pair of repairs, has always served adequately to the inhabitants of this part of Switzerland, and now has brought tourism to this place. Hundreds of people come every year to appreciate Salginatobel Bridge, a masterpiece of 20th century engineering which knew how to equilibrate utility, structural needs, economy, and the most pure beauty.